Hey everyone, it's Mr. Canfield. We're going to do section 1 of AP Calculus AB. This is the introduction, and we're just going to kind of go through this whole section together. This is going to be a pretty short one, but here we go. So before we get into what calculus is, here are several examples of what you could do BC, before calculus. BC, that's also my initials, so that's pretty fun. I did not write this book. A wonderful man named Stu Schwartz wrote this book, so every now and then I'll talk about Stu and what Stu did, just because Stu is such a cool name. Anyway, so let's see what example 1 says. It says, on April 15th, many people mail in their taxes to the International Revenue Service. Yeah, on April 15th, because that's when they're supposed to be due, even though, depending on the year, sometimes they're due in July. Anyway, the town of Newton monitors the number of tax forms that are mailed from the post office. The total number of tax forms that are mailed from the Newton post office on April 15th is modeled by this really simple looking function, 2500 over 1 plus 13 e to the negative 2.5, negative 0.25 t. Yeah, nice and relaxing. Nothing, no, woof, woof. It's a messy, but anyway, it looks like this. It winds up making this curve for us. Where t is the number of hours from 12 midnight on April 14th through 12 midnight on April 15th, and m of t is the total number of letters mailed that day from the Newton post office. So t is hours since midnight. So if t was 5, that'd be like 5 hours since midnight. That'd be 5 a.m. And m of t, remember m of t, that's this thing over here. Remember, that's a fancy way for us to write y. I tell that to my Algebra 1 students, but it works here too. It's a helpful thing for us to remember. M of t is, we're used to, instead of seeing m of t, we're used to seeing like f of x. F of x is a synonym for y. So y is the total number of letters mailed that day from the Newton post office. So in our BC days, but in our pre-calculus days, we could find the number of tax forms mailed by 9 p.m. on April 15th because, well, 9 p.m., that's 12 hours and then 9 more hours. That's 21 hours. We do m of 21. We could plug 21 into this function, get some number, we get approximately 2,340 letters. With calculus, we can find out all sorts of things. We can find out the average rate of tax forms mailed between 6 and 9 p.m. I'm not going to explain how we do these, but there are calculus methods for doing all these things. We could find how many tax forms are coming into the post office exactly at 9 p.m., well, exactly according to the function. A lot of times functions are close to the real thing. They're not exactly the real thing. We could find the time of day when the letters are coming into the post office at the fastest rate and what is that rate. So we're going to be able to, doing calculus, using some special techniques, we're going to be able to look at this and do some calculus and know when the slowest time is and when the fastest time is. Again, if this model is good. And then the total number of hours that all the forms sit in the post office. So we can see like, okay, if we were to put a stopwatch on every single one of these letters that comes into the post office, like boom, I get a letter, put a stopwatch on it, click, boom, get a letter, click, boom, put a letter, click. And we were to take every single tax form and just pile them up in the post office and them all have this stopwatch that started when they came in. And then all at the same time we hit click and stop them all at the exact same time. They'd all have different times on them. And we could go through and we could like read each stopwatch and write it down. Or there's a way to use some calculus and get it exactly in the blink of an eye. So the one thing that this doesn't talk about here that I think is worth mentioning is this function right here. We almost always are going to be given this function. Finding functions like this, it's a whole different story. We are going to essentially go, oh, I have this function, now I can do stuff with it. Calculus is manipulating those functions, at least at the beginning stages. So those are some things we do with calculus. We're going to skip this next example. Let's see. And we're going to come over here, we're going to talk about some vocabulary words. So the vocabulary words that we have are very useful. So it's worth noting. Let's see, pause, hold on, read. I get ahead of myself. all the math courses you've ever taken have been, in a sense, pre-calculus. So learning how to add, secretly, pre-calculus. We're trying to get you ready for calculus. I mean, kind of, but not really. But all the algebra we do, all the factoring we do, all the trig we do, that was to get us ready for calculus. In these courses, you're analyzing numbers and expressions and determining their current state. So if we want to find the value of x squared when x is equal to 4, we learned that we can plug 4 into that. 4 squared is 16. In calculus, we analyze how things change. In reality, the word calculus, there's a couple different meanings for it, but one of them is to calculate. Another one is there's this type of rock that they used for counting that had something to do with calculus. And the word calcium, you might notice that there's some overlap there. Anyway, so we're going to do some English right now. We want to find words that denote positive change, negative change, or no change. So we have some pretty simple mathematical ones. When stuck, think of real life areas. So one place we talk about positive change, we have increasing. Another thing that could talk about positive change is speeding up, right? We could talk about rising. We could talk about grows or growing. Let's see, another one. Think about your car or a car. Your right foot goes on the right pedal, presses down. Accelerate. So I've written 5. We could keep going and get more and more synonyms. But each of these has an antonym, right? An opposite. So speeding up, we have slowing down. Rising, we have falling. Growing, we have shrinking. Accelerating, we have decelerating. Let's see, no change. Speeding up, slowing down, staying the same. Oh, that's not as fancy sounding. Rising, falling, level maybe. Grows, shrinks, stunts their growth. Wait, no. Accelerate, decelerate, steady. Notice how no change has less. So anyway, calculus is all about change. And one thing I do want to note, we have 4 big topics that we talk about in calculus. They're limits, derivatives, integrals, which he has as 3, and Force 2 has them as 3 and 4. The 5th one that we have is called series, and that's where we look at adding up lots of terms like 1 plus 2 plus 3 plus 4. And we do calculus with that, but we do that in BC calculus. So that's kind of the C portion of this class. The A-B portion is like limits is kind of the A, and then derivatives is the B, and integrals is also kind of the B and a little bit of the C. And then the C portion is the rest of integrals and special topics and series. So, and if you are a junior taking my AB class, I would love for you to take BC next year. I know it's the first lesson, but just think about it. Okay, so again, most lessons are gonna be longer than this, but I just wanted to kind of give us a little something to go off of, something to start with. Normally it's gonna go from, so this is gonna say classwork, and then we'll turn the page and it'll be homework, but not this time. So that's that. There should be something next, though, after this. Bye.